Picture this: the last star flickers out, the final black hole evaporates into nothingness. The universe sits in perfect, frozen silence. Not a single atom moves. Time itself has run out. What comes next? Nothing, or something beyond our wildest imagination. Today we're diving into 30 theories about the ultimate fate of existence itself. From collapsing universes to cosmic resets, from simulated realities to divine interventions, we'll explore how everything might truly end. Some of these ideas will make your head spin. Others might keep you up at night, but one thing's certain: by the time we're done, you'll never look at the clock the same way again, so buckle up. We're about to take a journey to the very edge of eternity. Now, let's dive into our first theory, one that turns the cosmic story full circle. Imagine the universe not just expanding forever, but doing something far more dramatic, collapsing back in on itself. This is the Big Crunch, a scenario where everything that began with the Big Bang could end by reversing it. Here's how it works. Right now, the universe is expanding, galaxies drifting apart as space itself stretches. But gravity, the invisible force pulling everything together, might have the final say. If there's enough matter in the cosmos, enough gravity, the expansion could slow, stop, and then reverse. Picture all those galaxies, stars, and planets not just slowing down but hurtling back toward each other. Over billions of years, the universe would shrink, heating up as everything gets crammed into a smaller and smaller space. Scientists have spent decades measuring the expansion rate, trying to figure out if gravity will win this cosmic tug of war. For a while, it seemed possible until dark energy entered the picture. This mysterious force appears to be pushing the universe apart faster and faster. But some theories suggest dark energy might weaken over time, letting gravity take control again. If that happens, the collapse would be unstoppable. In the final moments of the Big Crunch, temperatures would soar beyond imagination. Atoms, molecules, even the fabric of space-time would be crushed into an infinitely dense point, a singularity, just like the one that birthed the universe. Some theories even suggest this singularity could trigger another Big Bang, starting the cycle all over again, a never-ending loop of creation and destruction. So, could this really happen? The answer hinges on mysteries we're still unraveling: dark energy, the shape of the universe, and the true strength of gravity. But one thing's certain: if the Big Crunch is our fate, the universe's grand finale would be as spectacular as its beginning. Now, let's shift our gaze to a far colder, quieter fate for the cosmos, one where the universe doesn't collapse in a fiery crunch but fades into an endless, frozen stillness. This is the heat death, also known as entropy's ultimate victory. Picture a cup of hot coffee left on the counter. Over time, it cools down, matching the room's temperature. The heat spreads out, never to return to the cup. The universe works the same way, but on a scale so vast it's hard to grasp. Entropy, a measure of disorder, always increases. Over trillions of years, this relentless march toward disorder will leave the cosmos in a state of maximum entropy, where energy is evenly spread out and nothing can happen anymore. First, the stars will burn out. One by one, they'll exhaust their nuclear fuel, vanishing into darkness. Galaxies will grow dim, leaving behind corpses of dead stars, white dwarfs, neutron stars, and black holes. Even these remnants won't last forever. Thanks to Hawking radiation, black holes slowly lose energy, evaporating over unimaginable timescales. The last black hole will vanish in a faint puff of particles, leaving behind only a sea of subatomic debris drifting in the void. By this point, the universe will be a vast, featureless graveyard. No temperature differences, no energy gradients, just a lukewarm haze where nothing moves, nothing changes. No new stars can form, no life can exist. Time itself might lose meaning, as there's no longer any process to mark its passage. Some scientists argue this is the most likely end game, given what we know about thermodynamics. Others wonder if quantum fluctuations or undiscovered physics might offer a way out. But for now, the heat death stands as a haunting reminder that even the universe isn't immune to the slow, inevitable decay of all things. Next, we'll explore a far more violent possibility, one where the universe doesn't fade away but is torn apart in a cataclysmic finale. Now, let's turn to a far more explosive and dramatic end, one where the universe doesn't fade or collapse but is violently ripped apart at every level. This is the Big Rip, a scenario where dark energy, the mysterious force accelerating the expansion of the cosmos, grows so powerful that it overcomes every binding force in nature. Imagine stretching a rubber band until it snaps. Now, picture that happening to everything: galaxies, stars, planets, even the atoms that make up your body. That's the Big Rip in action. Dark energy, which currently makes up about 68% of the universe's energy content, is pushing galaxies apart faster and faster. But what if this acceleration doesn't just continue? What if it intensifies? Recent measurements from telescopes like the Hubble Space Telescope and the Dark Energy Survey suggest dark energy's strength might not be constant. Some models propose it could grow stronger over time, eventually overpowering gravity, then electromagnetism, and finally the nuclear forces holding atoms together. First, galaxies would be torn from each other. Then, stars would be ripped from their galaxies, planets would be shredded from their orbits, and in the final moments, even atoms would be split apart, dissolving all matter into a soup of disconnected particles. The timeline for this catastrophe depends on dark energy's behavior. If it follows certain phantom energy models, the Big Rip could happen in as little as 22 billion years. But not all scientists agree. Some argue that dark energy's strength might plateau or even decrease, sparing the universe from this fate. Others point out that we still don't fully understand dark energy's nature. It might interact with itself or other forces in ways we haven't discovered yet. What's certain is that the Big Rip forces us to confront a terrifying possibility, that the very fabric of reality could one day be torn asunder, leaving no structure, no life, and no memory of what once was. Next, we'll examine an even stranger fate, one where the universe doesn't end with a bang, a crunch, or a rip, but with a silent, invisible rewrite of the laws of physics themselves. But what if the end of time doesn't come from something we can see or feel, but from an invisible shift in the very rules of reality? This brings us to vacuum decay, a theory so unsettling it makes the Big Rip seem almost gentle. Picture the universe as a fragile bubble floating in a higher energy state known as a false vacuum. It's stable for now, but lurking beneath the surface is a lower energy state, the true vacuum. And if even a tiny patch of space were to transition into this true vacuum, the consequences would be catastrophic. Think of it like a mountain lake frozen solid in winter. The ice seems stable, but somewhere deep below, a single crack forms. In an instant, that crack spreads, shattering the entire surface. Now, replace the ice with the Higgs field, the invisible quantum field that gives particles their mass. If this field is, as some theories suggest, not in its lowest possible energy state, then a random quantum fluctuation could trigger a bubble of true vacuum to form. This bubble would expand at the speed of light, rewriting the laws of physics as it grows. Atoms, forces, even the structure of space-time itself would be torn apart and reassembled under new rules. And here's the chilling part: we wouldn't see it coming. One moment, everything is normal. The next, an unstoppable wall of annihilation is already upon us, leaving no time to react, no chance to escape. The Higgs field stability is still an open question. Experiments at the Large Hadron Collider have narrowed down the possibilities, but we don't yet have definitive proof that we're safe. Some calculations suggest that if the Higgs boson's mass is just slightly different than what we've measured, the universe could be sitting on a knife's edge, vulnerable to collapse at any moment. Vacuum decay isn't just science fiction. It's a genuine possibility rooted in quantum field theory. and it forces us to confront the idea that the universe might not end with fireworks or ice, but with a silent, irreversible rewrite of existence itself. Next, we'll explore a theory that offers a very different vision, one where the end is just the beginning, and the universe cycles through endless rebirths. Now, let's turn to a theory that flips the script entirely. What if the end isn't really the end at all? Enter the cyclic universe, a mind-bending idea where the cosmos doesn't meet a final demise but instead resets itself in an endless loop of big bangs and big crunches. Imagine the universe as a cosmic phoenix, dying only to be reborn from its own ashes over and over again. This concept isn't just poetic speculation. It's grounded in serious physics like conformal cyclic cosmology, proposed by Nobel laureate Roger Penrose. Here's how it works. As the universe expands toward heat death, all matter and energy become so spread out that distances and time lose meaning. At this point, the universe's empty, high entropy state becomes mathematically identical to the conditions right before the Big Bang. In other words, the end seamlessly loops back into a new beginning with no boundary between cycles. But that's not the only version of this idea. String theory offers another twist: brain collisions. Picture our universe as a floating membrane or brain drifting in a higher dimensional space. When another brain collides with ours, the energy of the impact could ignite a new Big Bang, restarting the cycle. These collisions might happen at regular intervals like a cosmic heartbeat, with each collision birthing a fresh universe. One of the most fascinating questions here is, could anything survive between cycles? Some theories suggest that information, like the quantum states of particles, might somehow persist, carried over into the next universe. If true, this could mean traces of past cycles are hidden in the fabric of reality, waiting to be decoded. The cyclic universe theory challenges our linear view of time, suggesting that beginnings and endings might just be points on an infinite circle. It's a vision of the cosmos where destruction isn't permanent, but a prelude to renewal. And if it's correct, the end of time might just be the start of something new. Next, we'll dive into a theory that's even stranger, where the universe's emptiness might spontaneously create consciousness itself. Now, let's venture into one of the most bizarre and unsettling ideas about the end of time: the concept of Boltzmann brains. Picture a universe that's reached total heat death, where everything is cold, dark, and lifeless. In this vast, empty void, the laws of physics suggest something strange could happen. Random quantum fluctuations might, by sheer chance, assemble a fully conscious, self-aware entity out of the chaos. That's a Boltzmann brain, a lone mind popping into existence, complete with false memories of a past that never actually happened. At first glance, this sounds like science fiction, but it's rooted in real physics. The idea comes from Ludwig Boltzmann, a 19th-century scientist who studied entropy. He proposed that in an infinitely old universe, even the most improbable events like atoms randomly arranging themselves into a thinking brain would eventually happen. In a dead universe with nothing but time, these fluctuations could create not just one Boltzmann brain, but countless ones, each briefly conscious before dissolving back into the void. Here's where it gets even weirder. If Boltzmann brains are possible, then statistically, they'd be far more common than ordinary brains like ours, which evolved over billions of years in a structured universe. That raises a disturbing question. How do we know we're not Boltzmann brains ourselves, hallucinating reality as a fleeting glitch in an otherwise lifeless cosmos? Scientists push back against this idea because the odds of a Boltzmann brain forming naturally are astronomically low, far lower than the odds of our universe existing as it does. But the theory forces us to confront deep questions about reality, probability, and whether our perception of time and existence is as solid as we think. If Boltzmann brains are even remotely possible, it challenges our understanding of what's real and what's just a temporary blip in an endless sea of nothingness. Next, we'll explore an equally mind-bending possibility. What if our universe isn't real at all, but a simulation that could be shut down at any moment? Now let's shift gears to a theory that feels straight out of a sci-fi thriller. What if our entire universe is just an advanced simulation, and the end of time is as simple as someone hitting the off switch? This is the simulation shutdown hypothesis, and it's not just wild speculation. Philosopher Nick Bostrom laid out a compelling case for why this might not be as far-fetched as it sounds. Bostrom's trilemma presents three possibilities. Either civilizations like ours almost always go extinct before reaching advanced technological levels. They choose not to run ancestor simulations of their past, or we're almost certainly living in one of those simulations right now. If the first two options aren't true, the third becomes disturbingly likely. Think about it. If a future civilization could create hyper-realistic simulations of their ancestors, the number of simulated minds would vastly outnumber the real ones. Statistically, you're probably one of the simulations, but how would we even know? Some scientists suggest glitches in the fabric of reality could be clues. Unexplained gaps in physical laws, particles behaving in ways that defy logic, or even déjà vu might be signs of a programmed universe running into bugs. If the simulators decide the experiment is over or the system needs maintenance, they could just pull the plug, erasing our reality in an instant. This idea forces us to question not just the nature of time, but the nature of existence itself. If we're in a simulation, does time even have an independent reality, or is it just a variable in some cosmic code? And if the shutdown happens, would it be an end, or just a pause before someone boots up the next iteration? Up next, we'll dive into an even stranger twist on reality. What if death is just an illusion and consciousness finds a way to outlast the universe itself? Now, let's step into a reality where death might not be the end, just a shift in perspective. Quantum immortality is one of the most mind-bending theories about the end of time, suggesting that consciousness could outlast the universe itself. It all ties back to the famous Schrödinger's cat thought experiment, where a cat in a box is both alive and dead until someone observes it. But what if this isn't just about cats and boxes? What if it applies to us? The idea hinges on the many worlds interpretation of quantum mechanics. Every time a quantum event could go multiple ways, the universe splits into parallel timelines. In one, you might survive a deadly situation against all odds. In another, you don't. But here's the twist: your consciousness only experiences the timelines where you're still alive. From your perspective, you keep jumping to realities where you survive, no matter how improbable. It's like being the protagonist in a cosmic game of chance where the universe keeps dealing you winning hands. This gets even wilder when you think about the end of time. If the universe eventually dies, whether through heat death or a big crunch, your consciousness might still find a way to persist in some rare, improbable timeline where conditions allow life to continue. Subjectively, you'd never experience the end because your awareness would always land in a reality where existence somehow limps on. Of course, this raises eerie questions. If every possible outcome happens somewhere, does that mean there's a version of you witnessing the heat death of the universe, while another version is still sipping coffee in a timeline where Earth never formed? And if consciousness is just hopping between realities, does death even have meaning? Next up, we'll tackle a theory that flips time's arrow on its head. What if the universe starts running backward after entropy peaks? Now let's flip the script literally. What if time itself could run backward? The idea isn't just science fiction. It's rooted in something called CPT symmetry, a fundamental principle in physics that suggests the universe might look the same if you reverse charge, parity, and time. In simpler terms, if you could flip all the particles in the universe, mirror their positions, and run the clock backward, the laws of physics would still hold. This wild symmetry opens the door to a staggering possibility. After entropy, the universe's disorder, reaches its peak, time might start flowing in reverse. Picture this, stars wouldn't explode, they'd reassemble. Broken cups would leap off the floor and mend themselves. Light would travel back into bulbs instead of shining outward. Causality, the idea that causes come before effects, would flip on its head. You'd remember the future instead of the past, watching events unfold backward like a rewound tape. The psychological implications are dizzying. Would you feel like you're making choices, or would every decision feel predestined, as if the future is pulling you toward it? Some physicists argue this reversal could happen naturally. As entropy maxes out in the distant future, the arrow of time might lose its direction, leaving no preference for past or future. Others say it's mathematically elegant but practically unimaginable. Our brains are wired to perceive time moving forward, so a reversed flow might be impossible to experience. But if it did happen, would we even notice, or would it feel just as normal as time moving forward does now? This theory doesn't just challenge our understanding of the universe's end, it redefines what end even means. Instead of a finale, time might loop, reset, or invert, turning the cosmic story into one without a true conclusion. Up next, we'll explore a future where black holes aren't just lurking in space, they've taken over completely. Now, let's turn our attention to a future where darkness reigns supreme. Imagine a universe where black holes aren't just scattered cosmic anomalies, they're the last remaining structures, slowly merging into one colossal entity. This is the era of black hole dominance, a time when these gravitational giants become the universe's final rulers. Black holes are already some of the most powerful objects in existence, with gravity so intense that not even light can escape. But over unimaginable timescales, they'll begin to collide and merge, growing larger and more massive with each union. Picture a cosmic dance where these titans spiral toward one another, eventually forming a single, universe-spanning mega black hole. It's a chilling thought, the entire cosmos, once teeming with stars and galaxies, reduced to a solitary, all-consuming void. But even black holes aren't eternal. Thanks to Hawking radiation, a process where black holes slowly lose energy and evaporate, they'll eventually fade away. Here's how it works. At the edge of a black hole's event horizon, particles and antiparticles pop in and out of existence. Sometimes one particle falls in while the other escapes, stealing a tiny bit of the black hole's mass. Over trillions upon trillions of years, this drip feed of energy loss causes the black hole to shrink and ultimately vanish. Yet there's a twist, the information paradox, a puzzle about whether information swallowed by a black hole is truly lost, could change this outcome. Some theories suggest that information might escape during evaporation, encoded in the Hawking radiation itself. If true, this could mean black holes don't just disappear, they transform, leaving behind a faint imprint of everything they once consumed. Others argue that the paradox hints at deeper physics we don't yet understand, potentially rewriting the fate of these cosmic behemoths. So, will the universe end as a silent, black hole-dominated wasteland? Or will even these monsters fade into nothingness? The answer might lie in the delicate balance between gravity's grip and quantum mechanics quirks. Up next, we'll dive into an even more unsettling possibility. What if the very building blocks of matter aren't as stable as we think? But before we even reach the era of black hole dominance, there's another unsettling possibility lurking in the fabric of reality itself. What if the very building blocks holding matter together aren't as permanent as we assume? Let's talk about proton decay, a phenomenon that could unravel everything we know. Protons are the sturdy backbone of atoms, the tiny particles that give structure to all matter. For decades, scientists believed they were perfectly stable, enduring forever. But certain theories in particle physics suggest otherwise. If protons can decay, it means every atom in the universe, every star, planet, and even our own bodies has an expiration date. So how long would this take? Current estimates place proton decay on a staggering timeline of around 10 to the power of 34 years. That's a 1 followed by 34 zeros, an almost unimaginable span of time. But if it happens, the consequences are dramatic. Matter would slowly disintegrate, with protons breaking down into lighter particles like positrons and neutrinos. Over eons, galaxies would dissolve into a faint mist of subatomic debris, leaving behind a universe with no solid structures at all. Now you might wonder, how do we even test something like this? Enter the Super Kamiok, an experiment, a massive underground detector in Japan filled with ultra-pure water. Scientists monitor this tank for faint flashes of light, which could signal the rare decay of a proton. So far, no definitive evidence has been found, meaning protons are either far more stable than some theories predict, or their decay happens so slowly we haven't caught it yet. This leaves us with a haunting question. Is the universe destined to fade into a sea of particles, or will protons outlast even the most extreme cosmic timelines? The answer could redefine our understanding of matter's ultimate fate. And speaking of fundamental forces, our next theory takes us into the quantum realm, where the fabric of space-time itself might be at risk. Now, let's shift our gaze to a theory that turns the concept of a single universe on its head: eternal inflation. Imagine a cosmic foam, endlessly bubbling with new universes, each born from the same explosive process that created our own. This isn't science fiction. It's a serious idea rooted in the work of physicist Alan Guth, who proposed that the rapid expansion of space during the Big Bang might never truly stop. Instead, it could keep stretching outward in some regions, birthing countless pocket universes like ours in an ever-growing multiverse. Here's the twist. In this scenario, our universe is just one bubble in a vast, frothing sea of others. And as inflation continues, the space between these bubbles stretches faster than light can cross it, meaning we'd never reach another universe and they'd never reach us. We'd be forever isolated, trapped in our own cosmic pocket. Over time, this could lead to a chilling fate. Heat death might claim our bubble while others continue to thrive, their physics perhaps even allowing them to escape the same grim destiny. Why might some bubbles avoid heat death? It all comes down to the laws of physics within them. In eternal inflation, each new universe can have different fundamental constants. Some might have stronger dark energy, causing them to rip apart. Others might have weaker gravity, preventing stars from ever forming. But a rare few could strike the perfect balance, with conditions that allow for endless renewal, avoiding the slow fade into darkness. Guth's work suggests that our universe's fate isn't just about what happens inside it, it's about the infinite possibilities beyond. And if eternal inflation is real, then the end of time might not be a universal finale, but a lonely quietus for our bubble alone. Up next, we'll explore a theory that merges science with something far more unexpected: the idea that consciousness itself could shape the universe's ultimate fate. Now, let's take a surprising turn from the cold isolation of eternal inflation to a theory that blends science with something almost spiritual: the omega point. Picture this: a future where consciousness doesn't just survive the universe's end, but becomes its driving force, shaping reality itself. This idea comes from Teilhard de Chardin, a philosopher and paleontologist who saw evolution as a journey toward a cosmic climax. He believed that as complexity and consciousness grow, they'd eventually converge into a single, all-powerful point: the omega point, where mind and universe fuse into one. But here's where it gets even wilder. Physicist Frank Tipler took this idea and grounded it in hard science. He proposed that as the universe collapses toward its final moments, the energy density would become infinite, allowing an omnipotent intelligence to emerge. This intelligence, fueled by the universe's dying breath, could theoretically resurrect every being that ever lived, simulating their minds in a timeless, perfect state. It's like the universe's last act isn't destruction, it's a kind of digital immortality. How could this even work? Tipler's math suggests that in the final seconds of a collapsing universe, infinite computational power becomes possible. Every thought, memory, and experience could be recreated and preserved forever. It's a far cry from the cold emptiness of heat death or the violent chaos of the Big Rip. Instead, the end of time becomes a kind of transcendent awakening where consciousness escapes the limits of physics entirely. Of course, this theory sits at the edge of science and speculation. Critics argue that it leans too heavily on untested physics, while supporters see it as a hopeful counterpoint to the bleakness of other cosmic endings. But whether you buy into it or not, the Omega Point forces us to ask a profound question. What if the universe's ultimate purpose isn't just to fade away, but to become something greater than we can imagine? Up next, we'll dive into a theory that flips the script again, suggesting that reality itself might be nothing more than a cosmic hologram. Now, shifting our gaze from the cosmic awakening of the Omega Point, let's explore a theory that reimagines the universe itself as a vast, intricate hologram. The holographic principle suggests that all the information in our three-dimensional reality might actually be encoded on a two-dimensional surface at the edge of the cosmos, like a cosmic projector screen. Think of it this way: just as a hologram stores a 3D image on a flat piece of film, the universe could be storing everything we see, feel, and experience on a distant, invisible boundary. But here's the mind-bending part. If the universe is a hologram, it means there's a limit to how much information it can hold, just like a hard drive running out of space. As the universe expands, that information storage gets stretched thinner and thinner. Eventually, we could hit a point where the cosmic hard drive reaches maximum data density. What happens then? One possibility is that the universe simply can't store any new information. Time, change, and even causality might grind to a halt because there's no room left to record events. It's as if the universe freezes mid-frame, like a buffering video that never loads. Some physicists speculate that hitting this limit could trigger a catastrophic rewrite of reality. If information can't be created or destroyed, just rearrange the universe might start overwriting old data to make space for the new. Imagine your favorite book slowly having its pages erased and rewritten, one chapter at a time. Past events could literally fade away, replaced by new ones until nothing of the original remains. Of course, this raises eerie questions. If the universe is deleting its own history, how would we even know? And could consciousness or our perception of time be tied to this cosmic data flow? While the holographic principle is rooted in serious physics, like black hole thermodynamics and string theory, its implications for the end of time are still wide open for debate. Up next, we'll venture into another radical idea, a universe where dark matter suddenly shifts phase, reshaping reality in an instant. Now, let's turn our attention to something even more mysterious: dark matter. We've all heard how it makes up most of the universe's mass, yet we can't see it or touch it. But what if this invisible stuff suddenly decided to change its behavior? That's the heart of the dark matter phase transition theory. Picture this: dark matter, which has been quietly holding galaxies together for billions of years, undergoes a sudden shift like water, freezing into ice or evaporating into steam. If dark matter crystallized, it could form a rigid cosmic lattice, locking galaxies into place and halting their motion. Or worse, if it decayed, the gravitational scaffolding of the universe could collapse, sending stars and planets adrift in chaos. This idea isn't as far-fetched as it sounds. We've seen phase transitions before, like the Higgs field settling into its current state moments after the Big Bang, giving particles their mass. If dark matter has its own hidden field, a similar shift could rewrite the rules of reality. The scary part, it might happen without warning. One moment, everything's normal. The next, space-time itself could ripple with catastrophic distortions. Some theories suggest this transition could trigger a new Big Bang, resetting the universe entirely. Others warn it might tear apart the fabric of space, leaving behind a fractured cosmos. The truth is, we don't know. Dark matter remains one of physics' biggest puzzles. but one thing's certain: if it ever decides to change phase, the universe as we know it could end in an instant. Up next, we'll explore an even stranger idea. What if the universe isn't just a collection of matter, but a conscious entity itself? Now, let's take a step into the realm of the mind, not just human minds, but the mind of the universe itself. What if consciousness isn't something that just happens inside brains, but is woven into the very fabric of reality? That's the wild idea behind cosmic consciousness, a theory that suggests the universe might one day wake up, and when it does, time as we know it could come to an end. Think of panpsychism, the view that consciousness is a fundamental feature of all things, from atoms to galaxies. It's not that rocks are secretly thinking, but that the building blocks of reality might have some tiny spark of experience. Now imagine if all those sparks somehow synchronized, merging into a single, universe-spanning awareness. Integrated information theory, a framework for understanding consciousness, hints at how this could happen. By reaching a critical threshold of complexity, the cosmos might achieve self-awareness. Some scientists even tie this to the Gaia hypothesis, which sees Earth as a self-regulating system. Extend that idea to the entire universe, and you get a cosmos that's not just alive but awake. And here's where time gets weird. Linear time, the past, present, and future we're used to, might just be a side effect of limited, fragmented consciousness. If the universe truly wakes up, experiencing all moments at once, time could dissolve into a timeless now. This isn't just philosophy. Quantum experiments show particles behaving differently when observed, as if reality responds to awareness. Could the universe, in its final act, become its own observer, collapsing all possibilities into one eternal moment? It's a dizzying thought, but if consciousness is more than just brain activity, the end of time might not be an end at all. Just a cosmic eye-opening. Next up, we'll challenge time's very existence. What if it's all just an illusion? But what if time isn't just something we experience? What if it's something we invent? Here's a mind-bending twist. Time itself might be nothing more than a trick of the mind. That's the radical idea behind false time perception, a theory that suggests time doesn't exist as a fundamental feature of the universe. Instead, it could be a story our brains tell us to make sense of change. Take Julian Barber's timeless physics, for example. He argues that reality isn't a flowing river of moments but a frozen landscape of nows, like frames in a film reel, each one complete and unchanging. In this view, the past and future are just illusions. What we call time is simply our brain stitching together these static snapshots, creating the feeling of movement. It's not that the universe is evolving, it's that we're jumping from one now to another, mistaking the jumps for a continuous flow. This isn't just wild speculation. Some interpretations of quantum mechanics support the idea that time emerges from deeper, timeless laws. Even Einstein's relativity showed that time is flexible, bending and stretching depending on how you move. So if time isn't absolute, could it be purely subjective? Imagine a universe where every possible now exists simultaneously, like pages in a book. Turning those pages, that's the illusion of time. And here's the kicker: if time is just a human construct, its end might not mean the universe stops. It could mean we finally see reality for what it is, a vast, unchanging tapestry where every moment is equally real. No beginnings, no endings, just being. Next, we'll venture into something even stranger. What if white holes, the cosmic opposites of black holes, could resurrect the universe? Now, let's turn our attention to something that sounds like pure science fiction until you realize it might be real. White holes, the cosmic twins of black holes, could hold the key to a universe reborn. While black holes pull everything in, never letting go, white holes do the exact opposite. They spew out matter and energy, refusing to let anything in. If black holes are the universe's trash compactors, white holes are its fire hoses, blasting out new possibilities. Carlo Rovelli, a pioneer in loop quantum gravity, suggests these white holes might not just be theoretical oddities. His work hints that when a black hole dies evaporating through Hawking radiation, it could transform into a white hole on the other side. Picture this: a black hole collapses, but instead of vanishing, it flips inside out, erupting as a white hole in another universe or even our own distant future. It's like the universe hitting a cosmic reset button, recycling itself in a burst of new energy. And here's where it gets even wilder. Some theories propose that the Big Bang itself could have been a white hole event, a violent outburst of space-time and matter from some other universe's collapse. If that's true, our entire cosmos might be the aftermath of a white hole resurrection, with every galaxy, star, and planet born from the debris of a previous universe's death. Now, you might wonder, how could we ever spot a white hole? After all, if they're as elusive as they sound, wouldn't they be impossible to detect? Surprisingly, astronomers have already spotted bizarre cosmic explosions that don't fit the usual patterns. Some ultra-high-energy events, like certain gamma-ray bursts, could be white holes making their grand entrance. These flashes might be the fingerprints of a universe being born right before our eyes. So what does this mean for the end of time? If white holes are real, the universe might not have a true ending at all. Instead, it could be part of an endless cycle: black holes dying, white holes birthing new realities, and time itself looping in ways we're only beginning to imagine. The end of one story might just be the first page of another. Next up, we'll confront a terrifying possibility. What if the very fabric of spacetime unravels because quantum gravity itself breaks down? But before we dive into the chaos of unraveling spacetime, let's take a step back and ask a fundamental question. What if the rules holding our universe together just stop working? That's the terrifying premise of quantum gravity breakdown. For decades, physicists have struggled to reconcile Einstein's theory of relativity, which governs the cosmos on a grand scale, with quantum mechanics, the rulebook for the subatomic world. These two frameworks work flawlessly in their own domains, but when they collide, like near a black hole's singularity or in the universe's first moments, the math falls apart. And if we can't stitch these theories together, spacetime itself might not survive. Picture this: at the smallest possible scales, far tinier than an atom, spacetime isn't the smooth fabric we imagine. Instead, it's a seething quantum foam where tiny bubbles of space and time pop in and out of existence. This is the Planck scale, where gravity and quantum effects battle for dominance. Normally, this foam is stable, but if quantum gravity fails to tame it, the foam could go haywire. Imagine a calm ocean suddenly churning with uncontrollable whirlpools, tearing apart anything that floats on it. That's what might happen to spacetime if quantum gravity breaks down. Regions of the universe could dissolve into chaos, with distances and times losing all meaning. Some theories, like loop quantum gravity, suggest gravity might not even be a fundamental force. It could emerge from deeper quantum processes, like temperature emerging from the motion of atoms. But if this emergent gravity model is wrong, or if the underlying quantum structure fractures, gravity could vanish or warp unpredictably. Stars might wobble out of orbit, planets could crumble, and light itself might bend in impossible ways. The scariest part: we might not see it coming. A quantum gravity breakdown could start in some distant corner of the cosmos, spreading like a crack in ice until the entire universe's structure shatters. Or it could happen everywhere at once, rewriting physics in an instant. Either way, time as we know it would cease to exist, not with a bang, not with a whimper, but with a silent mathematical inconsistency. Now, let's shift gears to another cosmic wildcard. What if our universe isn't just a one-time event, but a rare statistical fluke in an endless sea of chaos? That's the bizarre premise of our next theory. Now, let's take a detour into one of the most mind-bending ideas in cosmology. What if our entire universe is just a fleeting blip in an endless sea of randomness? This is the Boltzmann universe fluctuation theory, named after physicist Ludwig Boltzmann, who first toyed with the idea that entropy, the measure of disorder in a system, might not always increase. Here's the wild part. In an infinitely old universe where entropy has already reached its maximum, a state known as thermal equilibrium, tiny, random fluctuations could still occur. Most of these fluctuations would be minor, like a single atom moving out of place, but given enough time, even the most improbable events become possible. That includes the spontaneous formation of an entire universe like ours, complete with galaxies, planets, and conscious beings. Think of it like this. Imagine a box filled with gas where every molecule is perfectly evenly distributed maximum entropy. Now, by sheer chance, all the molecules suddenly crowd into one corner. That's astronomically unlikely, but in an infinite timeline, it has to happen eventually. Our universe could be that freak accident, a temporary dip in entropy that created order out of chaos. The numbers are staggering. The probability of our universe appearing this way is something like 1 in 10 to the power of 10 to the power of 123. To put that in perspective, it's more likely you'd win the lottery every day for your entire life while being struck by lightning twice each time. Yet, if the cosmos is truly infinite, even these odds become inevitable. But here's where things get even stranger. If our universe is just a random fluctuation, does that mean the Big Bang wasn't a unique event? Could there be countless other universes popping in and out of existence, each a fleeting pocket of order in an otherwise lifeless void? Some physicists argue this makes the Big Bang cyclical in a sense, not because the universe collapses and rebounds, but because these improbable fluctuations keep happening over and over. Of course, this raises unsettling questions. If we're just a statistical anomaly, how do we know our memories or the laws of physics aren't also random illusions? And if Boltzmann fluctuations can create conscious observers, why aren't we surrounded by disembodied brains floating in space? A thought experiment cheekily called Boltzmann Brains. The theory walks a fine line between profound insight and cosmic absurdity. Next up, we'll explore an even more radical idea. What if reality isn't just governed by math, but is math? That's the startling claim of our next theory. Now, let's shift gears to a theory that flips everything we think we know about reality on its head. What if the universe isn't just described by math? What if it is math? This is the core idea behind the mathematical universe hypothesis, championed by physicist Max Tegmark. He proposes that reality isn't merely governed by mathematical laws, but is, at its deepest level, a purely mathematical structure. No particles, no forces, just numbers and equations playing out in an abstract space. Think of it like a video game. In a game, everything, the characters, the physics, even the story, is just code running on a computer. The mathematical universe hypothesis suggests our reality works the same way. The code is math, and we're part of that computation. Tegmark calls this the level 4 multiverse, where every possible mathematical structure exists as its own separate universe. Some might have familiar physics like ours, while others could be so alien we can't even imagine them. Here's where time gets weird. If the universe is just math, then time might not be fundamental at all. It could be an emergent property, like temperature emerging from the motion of atoms. In this view, the end of time might simply be the universe reaching a state where the equation no longer produces change, a static, eternal answer to a cosmic math problem. No ticking clock, no entropy, just a frozen snapshot of all possible states. But what does that mean for us? If time isn't real, then our sense of past, present, and future could be an illusion. Tegmark argues that in a mathematical universe, every moment that can exist does exist, somewhere in the vast landscape of equations. The end would just be one point in an infinite tapestry of mathematical truths. Critics push back, asking why we perceive a flowing time if it's not fundamental. Others wonder whether math alone can explain consciousness or the subjective experience of being alive. But if Tegmark is right, the ultimate fate of the universe might not be a fiery collapse or a frozen void. It might just be the final line of a cosmic equation quietly solved. Up next, we'll dive into a theory that's as eerie as it is plausible. What if ghostly particles we barely understand could spell doom for everything? That's the neutrino apocalypse, and it's coming right up. Now, let's turn our attention to something far more subtle yet potentially catastrophic: the quiet menace of neutrinos. These ghostly particles, nearly massless and barely interacting with matter, might seem harmless. But what if, over unimaginable stretches of time, they become the universe's silent executioners? This is the chilling premise of the neutrino apocalypse. Neutrinos are everywhere. Trillions pass through your body every second without a trace. They're produced in stars, supernova, even nuclear reactions here on Earth. Right now, they're harmless, slipping through planets like they're not even there. But here's the twist. Some theories suggest that over billions or even trillions of years, relic neutrinos, those left over from the early universe, could gain mass. If that happens, their weak interactions might strengthen, turning them into destructive forces. Imagine a future where these once ghostly particles start colliding with atoms. At first, it's rare, but over eons, it adds up. They could destabilize atomic nuclei, causing matter to slowly unravel. Stars, planets, even black holes might decay as neutrinos chip away at their structure. The Ice Cube Neutrino Observatory in Antarctica has been tracking high-energy neutrinos from cosmic events, giving us clues about their behavior. While current data shows no signs of this doomsday scenario, the sheer timescales involved mean we can't rule it out. The real question is, how could neutrinos gain destructive power? One possibility ties into dark matter. If neutrinos interact with hidden particles or fields, their properties might evolve over cosmic time. Another idea is that the universe's expansion could somehow energize them, turning them from phantoms into wrecking balls. Of course, this is speculative. Most physicists think neutrinos will remain harmless forever. But in a cosmos where time stretches to infinity, even the faintest whisper of interaction could become a roar. The neutrino apocalypse isn't about fire or ice, it's about the slow, invisible erosion of reality itself. Next up, we'll venture into the realm of higher dimensions, where colliding cosmic membranes could rewrite existence in an instant. The brain collision apocalypse awaits. Now, let's step beyond the familiar dimensions of space and time into a realm where reality itself is just a thin slice of something far grander. Picture our universe not as an isolated bubble, but as a floating membrane, or brain, drifting through a higher dimensional space called the bulk. And here's the twist: there could be other brains out there, lurking in the darkness on a collision course with ours. This is the brain collision apocalypse, a scenario where two universes smash together with unimaginable force. According to ekpyrotic models inspired by string theory, such collisions could be cyclical, a cosmic reset button. One moment, everything exists as we know it. The next, a higher dimensional impact rewrites the laws of physics, wiping the slate clean. It's like two sheets of paper slamming together in a vast, unseen wind, except those sheets contain entire galaxies, stars, and us. Why should we care? Because if extra dimensions exist, the Large Hadron Collider might find clues. Scientists are searching for particles that briefly disappear into higher dimensions or unusual energy signatures that hint at hidden layers of reality. A detection could mean we're not alone in the bulk and that another brain might be headed our way. The terrifying beauty of this theory is its scale. A collision wouldn't just destroy planets or stars, it would erase space-time itself, replacing our universe with something entirely new. Some models even suggest this could explain the Big Bang, not as a singular beginning, but as the aftermath of a cosmic crash. Of course, this remains speculative, but if brains are real, the end could come without warning, rewriting existence in an instant. And that raises a haunting question. If universes collide and reboot, how many times has it already happened? Next, we'll confront a mind-bending idea. What if reality depends on us watching it? The consciousness collapse theory suggests the universe might unravel if we stop looking. Now, let's take a sharp turn into one of the most unsettling ideas in physics. What if reality itself depends on us being here to witness it? This is the consciousness collapse theory, where the act of observation doesn't just measure the universe, it might actually hold it together. At the quantum level, particles exist in a haze of possibilities until someone or something observes them, forcing them to choose a state. This is the famous observer effect, seen in experiments like the double-slit test, where particles behave differently when watched. But what if this principle scales up? What if sentient beings, by merely perceiving the universe, keep it from dissolving back into uncertainty? Some interpretations of quantum mechanics suggest that without conscious observers, the wave function, the mathematical description of quantum states would never collapse. Reality would remain a blur of probabilities, never settling into the solid world we know. In other words, the universe might need us as much as we need it. This idea ties into the anthropic principle, which argues that the universe's laws seem fine-tuned for life because only in such a universe could life exist to notice them. But the consciousness collapse theory takes it further, proposing that observation isn't just a passive accident, it's an active glue holding existence together. Critics argue this veers into philosophy, not science. After all, how could we test whether reality vanishes when we're not looking? Yet, it raises a chilling thought. If humanity, or all conscious life, were to disappear, would the stars, galaxies, and even time itself flicker out like an unobserved quantum particle? Next, we'll venture into the realm of infinite curvature, where time itself might twist into a knot. The temporal singularity theory suggests a point where time's flow becomes so distorted, it ceases to function altogether. Now, let's stretch our minds even further. What if time itself could tie itself into a knot? This is the temporal singularity theory, where the very fabric of time becomes so twisted, it reaches a point of infinite curvature. Imagine time not as a straight line but as a rubber band stretched to its limit, warping until it snaps. At the heart of this idea is the concept that time, much like space, can bend under extreme conditions. We already know black holes create gravitational singularities, points where density becomes infinite and space-time breaks down. But what if time, not just space, could reach a similar breaking point? Roger Penrose, the Nobel Prize-winning physicist, proposed something called conformal cyclic cosmology, where the universe's end might not be an end at all, but a boundary where time resets. In this scenario, time's curvature grows infinitely steep, like a roller coaster climbing an impossible peak. At the singularity, the rules of cause and effect could unravel. Past, present, and future might blur into a single moment, making before and after meaningless. It's as if the universe hits a cosmic pause button, freezing in an eternal now. Some theories suggest this could happen if dark energy grows stronger, accelerating expansion until time itself stretches thin. Others tie it to quantum gravity, where tiny fluctuations at the smallest scales could cascade into a space-time meltdown. Either way, the result is the same: time ceases to function as we know it. But here's the twist: Penrose's conformal boundary idea hints that a temporal singularity might not be the end. Instead, it could be a gateway, a reset point where a new universe emerges from the ashes of the old. If true, time's death might just be the birth of something entirely new. Next, we'll dive into one of the most puzzling questions in physics: what happens to information when black holes vanish? The information paradox could rewrite how we see time's ultimate fate. Now, let's untangle one of the most baffling puzzles in physics: the black hole information paradox. Picture this: when matter falls into a black hole, it's supposedly crushed into oblivion, leaving no trace behind. But here's the problem: quantum mechanics says information can never truly be destroyed. So where does it go? This paradox could hold the key to understanding time's ultimate fate. At the heart of the debate is Stephen Hawking's discovery that black holes slowly evaporate, leaking radiation over unimaginable timescales. But if the black hole vanishes, what happens to all the information it swallowed? Some physicists argue the information is scrambled and released in the Hawking radiation, like a cosmic recycling program. Others propose a wilder idea, the firewall paradox. Imagine hitting a wall of searing energy at the event horizon, where the laws of physics as we know them break down. This firewall would destroy any falling object before it reaches the singularity, preserving information but rewriting how we think about black hole interiors. Then there's the ER equals EPR connection, a theory so elegant it sounds like science fiction. It suggests entangled particles, those spooky quantum twins, might be linked by microscopic wormholes or Einstein-Rosen bridges. If true, information could escape black holes through these hidden tunnels, avoiding destruction entirely. This idea blurs the line between quantum mechanics and general relativity, hinting at a deeper structure to spacetime itself. Solving the information paradox wouldn't just tidy up physics, it could redefine how time ends. If information persists even through black hole evaporation, it suggests time might have a kind of memory, a way to preserve events long after they seem lost. Alternatively, if firewalls or wormholes reshape black hole physics, they might also alter the universe's final moments. Could information survival mean time never truly ends, just transforms? Next, we'll step into a philosophical whirlwind, the idea that history repeats itself endlessly. Eternal recurrence isn't just a poetic thought experiment, it has surprising roots in modern physics. Now, let's shift gears to a theory that blends philosophy with physics, the idea that everything that's happened will happen again, endlessly. This is eternal recurrence, a concept famously championed by Friedrich Nietzsche, but it's not just poetic musing. Modern physics gives it a surprising twist. At its core, eternal recurrence suggests the universe repeats itself in identical cycles. Every moment, every choice, every star and galaxy reborn exactly as before. Nietzsche posed it as a thought experiment. If time is infinite and matter finite, shouldn't every possible arrangement of particles eventually repeat? Fast forward to today, and the Poincaré recurrence theorem gives this idea mathematical legs. It states that in a closed system with finite energy like our universe, given enough time, every configuration of matter will recur. We're talking timelines so vast they make billions of years feel like a blink. But here's where quantum mechanics spices things up. Quantum state recurrence suggests even tiny particles might revisit past states given enough time. Imagine flipping a coin forever. Eventually, it'll land heads or tails in the exact same sequence as before. Scale that up to the universe and you get a mind-bending possibility, history repeating down to the last atom. Critics argue this ignores entropy, the universe's tendency toward disorder. Yet some theories, like conformal cyclic cosmology, propose workarounds. If the universe resets at maximum entropy, stretching and smoothing out all structure, maybe recurrence isn't just possible but inevitable. Whether you see eternal recurrence as a profound truth or a cosmic quirk, it forces us to ask, if time is cyclical, does an end even exist? Or are we stuck in a loop where beginnings and endings blur into one? Now, let's venture into a theory that sounds like science fiction but is rooted in cutting-edge physics: dimensional unraveling. Picture this: the very fabric of our universe, the 4 dimensions we know, 3 of space and 1 of time, begin to come apart. This isn't just a cosmic disaster movie plot. It's a real possibility explored by string theory, one of the most ambitious frameworks in modern physics. String theory suggests our universe might actually have more dimensions than we can perceive: tiny, curled-up dimensions hidden at scales so small they're beyond our detection. These extra dimensions are compactified or tightly wound like the coiled strings of a guitar. But what if they started to uncurl? Imagine a thread unraveling from a spool, except this thread is a dimension of space-time itself. If these hidden dimensions were to loosen or expand, the consequences would be catastrophic. Our familiar four-dimensional reality could dissolve, rewriting the laws of physics in an instant. The string theory landscape, a vast array of possible configurations for these extra dimensions, hints that some universes might be stable while others are teetering on the edge of collapse. In this scenario, a quantum fluctuation or a shift in energy could trigger a dimensional phase transition, like ice melting into water, but with space-time itself as the medium. Suddenly, gravity might behave differently, particles could gain or lose mass, and the very structure of matter would transform. Some physicists argue this could explain why our universe seems so finely tuned for life. If other dimensions exist but remain stable, we might simply be in a pocket of reality where the unraveling hasn't happened. Yet, others warn that if the compactified dimensions destabilize, it wouldn't just be the end of time. It would be the end of space, matter, and everything we recognize as reality. So, are we living in a cosmic house of cards, one vibration away from collapse? Or is dimensional unraveling just one of many wild possibilities in the multiverse? Either way, it's a reminder that the universe might be far stranger and more fragile than we ever imagined. Now, shifting our gaze from the cold equations of physics to the realm of the divine, let's explore a theory that has captivated human imagination for millennia: divine intervention. Across cultures and religions, the end of time isn't just a scientific inevitability but a cosmic drama orchestrated by higher powers. From Norse mythology's Ragnarok, where gods and monsters clash in a fiery finale, to Christianity's Judgment Day, where souls are weighed and the world is renewed, these narratives share a common thread: time's end is purposeful, even moral. But how does this square with modern cosmology's impersonal, mechanical view of the universe? Science describes the end of time through forces like entropy or dark energy, processes indifferent to human existence. Yet, some physicists point to the eerie fine-tuning of the universe, the precise constants that allow life to exist, as potential evidence of something more. Could there be a designer behind the cosmic clock, or is fine-tuning just a staggering coincidence? The debate rages on. Skeptics argue that invoking divinity is a retreat from scientific inquiry, while others see room for both perspectives. After all, even Albert Einstein famously pondered whether God had any choice in creating the universe. Whether you see the end of time as a divine reckoning or a natural process, one thing is clear: these stories reflect humanity's deepest hopes and fears about our place in the cosmos. So, is the universe winding down toward a silent heat death, or is it building toward a grand, intentional finale? The answer may depend on whether you're looking through the lens of a telescope or a scripture. Either way, the question lingers: in the end, will there be meaning or just physics? Now, let's take a leap from ancient prophecies to the cutting edge of futurism, where technology and cosmology collide in a mind-bending finale. Imagine a scenario where humanity doesn't just witness the end of time but actively reshapes it. This is the Omega singularity, a theory that blends Ray Kurzweil's vision of a technological singularity with the grand scale of cosmic destiny. Picture this: as artificial intelligence surpasses human intellect, it doesn't stop at solving earthly problems. It turns its focus to the universe itself. A post-human civilization, whether biological, digital, or something beyond, could harness the energy of stars, manipulate space-time, or even rewrite the laws of physics to escape entropy's grip. Some theories suggest such beings might create new universes, resetting existence in a cosmic act of rebirth. Others propose they'd transcend into higher dimensions, leaving our dying cosmos behind. But here's the twist: this isn't pure science fiction. The seeds of this idea lie in real physics. Concepts like black hole engineering, quantum computing, and the holographic principle hint at ways advanced intelligence might one day bend reality to its will. Even the idea of a mathematical universe where reality is fundamentally computational aligns eerily with the notion that a superintelligence could reprogram existence. Of course, skeptics question whether any intelligence, no matter how advanced, could defy the universe's ultimate fate. Yet, if the omega singularity is possible, it flips the script on the end of time entirely. Instead of a passive cosmic shutdown, the universe's finale becomes a conscious choice, a testament to life's potential to outlast even the stars. So, will the last act of time be a whimper or a rewrite? The answer might depend not on gods or physics alone, but on what we or our descendants become. And so, we've journeyed through the cosmos, from the crushing grip of the Big Crunch to the eerie silence of heat death, from the quantum unpredictability of vacuum decay to the transcendent possibilities of the omega singularity. Each theory paints a different portrait of time's end, some bleak, some bizarre, and a few that spark a glimmer of hope. The wildest ideas, like Boltzmann Brains or simulation shutdown, challenge our very perception of reality, while the more grounded ones, like proton decay or eternal inflation, remind us of the universe's relentless physics. Yet, whether it's the cyclical rebirth of the cosmos or the cold fade into nothingness, one thing is clear. The end of time isn't just a scientific question, it's a mirror held up to humanity's curiosity, our fear, and our unshakable drive to make meaning of the infinite. Carl Sagan once said that we are a way for the cosmos to know itself. Maybe that's why these theories captivate us so deeply. They're not just about endings, they're about understanding our place in a story far grander than we can fathom. So, which theory resonates with you? Do you see the universe collapsing, freezing, or transcending? Drop your thoughts in the comments below. We'd love to hear your cosmic perspective. And if this voyage through time's ultimate mysteries left you hungry for more, don't forget to hit that subscribe button and ring the notification bell. There are endless wonders to explore, from black holes to multiverses, and we're just getting started. Until next time, keep looking up and wondering what lies beyond the final tick of the cosmic clock.